Hello everyone. Title of this video is Solve Applications with Absolute Value. So these will be applications in which we set up an absolute value inequality. And all the examples I'm going to do, all the exercises I'm going to do are from a free online textbook from openstacks.org. This book is the Intermediate Algebra 2nd edition. And I'm looking at some exercises from section 2.7 titled Solve Absolute Value Inequalities. And I'll be working on problems 490 through 493 with the heading Solve Applications with Absolute Value. And all we're asked to do is, in the following exercises, solve. Alright, and before I get to these actual problems, I want to talk a little bit about how the distance between two numbers can be expressed using absolute value. All right. So here's some paper here. Distance between two numbers on the number line. Right. Right. So the distance between two numbers, say here's the number line, and I have numbers A and B. All right, now the distance between them is this length here that I'm highlighting in this color marker, right, this pink. There's the distance between A and B. And typically, you just do the right number minus the left number, right? B minus A equals, distance between A and B. But sometimes, right, this doesn't end up being negative. What if I mess it up? So for example, what's the distance between 5 and 7? Now if you did 7 minus 5, right, that would be 2. That would be correct, right? Distance is not negative, right, when you're talking about distance, right? Distance should be a non-negative quantity. But what if I messed up and I did 5 minus 7 instead? Well, that would be negative 2, and I would be incorrect in saying that that's the distance. So to ensure that we get a non-negative response for the distance between two numbers, take the absolute value. Right, make that positive 2, and do the same thing even if it is positive already. You end up with positive 2. So a more proper expression for the distance between A and B is the absolute value of B minus A, or the absolute value of A minus B, because it doesn't really matter. Right? Absolute value of 7 minus 5 is 2. The absolute value of 5 minus 7 is 2. So A minus B, B minus A, you're taking the absolute value. That's the distance between two numbers expressed in terms of absolute value. I hope that makes sense. Alright, so keeping this in mind, talking about the distance between numbers, let's get to the exercises. Alright, so example 1 is going to be number 490. And it says here, a chicken farm ideally produces 200,000 eggs per day. But this total can vary, right, by as much as 25,000 eggs. The question is, what is the maximum and minimum expected production at the farm? Now I know this is easy to do. You can just say, hey, take the 200,000 that they'd ideally produce and that can vary by 25,000, so change by 25,000, meaning add 25,000, subtract 25,000, and then the expected production can be anywhere from 175,000 to 225,000. I mean, like I just said that out loud. You can do all that in your head probably. But just as with any other word problem or any other application problem, I'm going to approach it the same way as in other videos where I've done applications. So I read through the problem. This will be example 1. And then I identify unknowns. Right? Unknowns. What do they want? What are they asking me for? So they're asking the question, what is the maximum and minimum expected production at the farm? So how about the production at the farm? Also known as the number of eggs the farm produces in a day. Right, number of eggs produced by the farm. I don't know what this is, right, day to day, because again it can vary, right? It is a variable. They said this total can vary, right? So I'm going to call this X. Right? So the number of eggs produced by this farm in a day is X eggs. Right. Now they said that the ideal production, right, if they were doing it ideally, in a perfect world, the ideal production in a day is 200,000 eggs. But they're saying that this total can vary by as much as 25,000. So I'll say it this way, right? The distance, using the concept of distance like I had on my previous page, I'll say, the distance between what the farm actually produces, which is X eggs, and what the farm wants to produce, right, the ideal production, right, the distance between what the farm produces, X, and what they want to produce can be as much as 25,000. Right, that's what they're saying when they say that this total can vary by as much as 25,000 eggs. I hope that makes sense in a way. Right. And then I'm going to take my phrasing here, right? This is probably the hardest part in any application or word problem. Right? It's reading back through the problem and being able to phrase things in a way that you can translate to math. You can translate into either an equation or an inequality or a system of equations, system of inequalities, whatever. So you see here the distance between X, right, the farm production, and the ideal production in a day. If you go based on what I talked about on the previous page about the distance between two quantities being the absolute value of their difference, this is the absolute value of X minus 200,000. Right. This is, you take how many eggs the farm produced in a day, subtract how much they liked to have produced, and according to what they said, this can vary. This difference can be at most, can be as much as 25,000. So can't be higher than 25,000, right? It can be as much as 25,000. That means that this distance is going to be less than or equal to 25,000. Right? So here it is. Right now I'm not done, but look, I've set up this, this absolute value inequality, which is going to be done for each of these exercises. And I'm hoping that you have seen my other videos where I took you through exercises of solving these absolute value is less than some number videos. So now we'll go about solving this thing. All right, now remember, when you have an absolute value inequality, you isolate the absolute value expression, which I have done here. All right, the absolute values alone on the left side is less than or equal to some positive number, right, positive 25,000. And the only way this is going to happen here, once you've isolated the absolute value, you then write an equivalent expression. Right? This is equivalent to the following compound inequality. X minus 200,000 must be between then 25,000 and negative 25,000. And hopefully, again, you remember, I'm assuming you have seen how to perform this, how to solve absolute value inequalities at this point. And then to solve for the variable x, how many eggs the farm expects to produce or wants the expected production each day, I would just add 200,000, get the variable along the middle. So adding 200,000 to this would give me 175,000 over here. On the low end is less than or equal to x, and that's less than or equal to adding 200,000 would give me 225,000 over here. And there we go. All right, now as with any other word problem, most applications you should be solving by answering the question in a complete sentence. So my answer here, based on the results of this solving of the inequality, I would say the expected production at the farm ranges from 175,000 eggs a day to 225,000 eggs a day. All right, so I'll just say the production at the farm, which was represented by X. The production at the farm ranges from 175,000 eggs a day to 225,000 eggs a day. All right, I know I said this out loud at the beginning without actually writing out any math. Right? I took 200,000 and just added 25,000, subtracted 25,000. That's really all you need to do here. But I just wanted to show you, how you would interpret this mathematically, right? Translate it into some sort of inequality involving variables and mathematical statements. Okay, so hopefully that made sense. Because the next one is very similar. All right, example 2, number 491. Again, very, very similar. But instead of a farm, it's about an organic juice bottler. An organic juice bottler ideally produces 215,000 bottles per day. But this total can vary by as much as 7,500 bottles. What is the maximum and minimum expected production at the bottling company? So again, for the maximum, I would just take what they want to produce, and it can be you can be off by plus or minus 7,500. So I would add 7,500 to get a 222,500 bottles per day for the maximum production, and then subtract 7,500 to get 207,500 bottles for the minimum expected production at this bottling company. But if I were to try to set up an absolute value inequality like they're expecting, so that's example 2. Again, I'll say the production at the bottling company, right? The number of bottles produced a day, I don't know, right? Because again, it varies day to day. It can vary off of 215,000 by as much as 7,500 bottles. So the production at the bottling company, again, I'll call this P for production. I called the last one X. Doesn't matter. Just call it something. So they produce P bottles a day. Right, let's say P bottles. And then just as before, the difference or distance between the amount of bottles they produce, right, between P and the amount of bottles they'd like to produce, right, the ideal production, which is 215,000, that distance, that difference, right, can be as much as, can vary by as much as, or be as much as 7,500 bottles. And there's a statement I'm writing that will be easily translated into an absolute value inequality, very similar to the first example. Right, again, this difference or distance between the bottles produced and the ideal production, 215,000 bottles, that's the absolute value of P minus 215,000. Or you could say 215,000 minus P, same thing. You'll end up with the same solutions at the end, I promise you. Can be as much as, right, that means no greater than, less than or equal to 7,500, right? So again, very, very, very similar setup. And then I want to solve this for P to give me a range of production values for this company day to day. So I've got the absolute value alone already on one side is less than or equal to some positive number. I can write the equivalent. This inequality is equivalent to the following compound inequality. This will be true if this P minus 215,000 is between, right, or equal to positive 7,500 and negative 7,500. And again, I'm assuming you know a little bit about solving absolute value inequalities from a previous video or previous exercises or previous reading. And then I solve this by getting P alone in the middle, adding 215,000. So we have 207,500 here on the left is less than or equal to P, and that's less than or equal to 222,500 on the right. And there's a description. Now we would describe this in a full sentence. So again, the answer here, the production for this bottling company, I'll just say the production would ranges from 207,500 bottles a day to 222,500 bottles a day. So the production ranges from 207,500 bottles to 222,500 bottles per day. All right, there you go. All right, you should be doing this with most applications, most word problems, right? Writing your final result, your final observation, your final answer in complete sentences. All right, and I guess more specifically, right, the minimum expected production would be 207,500 bottles a day. The maximum expected production would be 222,500 bottles per day. Okay. Again, very similar setup. Yes, you heard me do it out loud without writing the math, but I just wanted to show you that you should be able to express things mathematically. All right, example 3. And I think all 4 of these actually have a similar setup, where we have the absolute value of some expression less than or equal to some positive number. All right, so third example, number 492 here. In order to ensure compliance with the law, Miguel routinely overshoots the weight of his tortillas by half a gram, 0.5 grams. He just received a report that told him that he could be losing as much as $100,000 per year using this practice, right? So overshooting, overestimating or over making the tortillas by up to half a gram is costing him money, right? Putting out too much and not making enough back. So he now plans to buy new equipment that guarantees the thickness of the tortilla to be within 0.005 inches. If the ideal thickness of the tortilla is 0.04 inches, what thickness of tortillas will be guaranteed? All right, so they're asking about the thickness of these tortillas. So this is unknown. I'll call this T for thickness, or tortilla, whatever you want. So the thickness of a tortilla is T inches. Right, they gave us a thickness in inches there. Now, according to this new equipment guarantees that the thickness it guarantees the thickness of, it says the machine guarantees tortilla thickness within 0.005 inches of the ideal, I'm assuming, right? As it says, the ideal thickness of the tortilla is 0.04 inches. This equipment guarantees the thickness to be within, 5/1000ths of an inch of the ideal, right? I'm assuming that's of what you want, right? It's within 5/1000ths of an inch of what you want, right? We want a 0.04 inch thick tortilla. So all this is saying is that, and again, they use the concept of distance. All this is saying is that the distance, or the difference, but positive, right, non-negative, the distance between the thickness of a tortilla and the ideal thickness when using this equipment is within 0.005, so no more than 0.005 inches. Right, so we got this set up. All right, and I guess I should have written the inequality here, right? So the absolute value of t minus 0.04 is less than or equal to 0.005, right? Again, what this means is that if they took a tortilla and then subtracted 0.4, right, 0.04 inches, that distance, and then the absolute value, that distance, that difference between the thickness of the tortilla and what he actually wants, is going to be within, right, less than or equal to 0.005. In fact, it might just be less than if it's going to be within, but I'll say less than or equal to. All right, then as before, we set up our inequality here. This would be equivalent to t minus 0.04 is between negative 0.005 and positive 0.005. And then to solve for t here, the thickness of, what the thickness of the tortillas he can make range between, I would add 0.04 to everything. All right. Well, this is 40 thousandths minus 5 thousandths. That'd be 35 thousandths right over here, 0.035, and add over here 0.045. Right. Now, in a sentence, what this is saying is that using this equipment, Miguel is guaranteed to make tortillas within, the thickness of 0.035 inches and 0.045 inches. So Miguel is guaranteed to make tortillas with thickness ranging from 0.035 inches to 0.045 inches. And there's your nice complete sentence describing what that solution of the inequality is saying. So yeah, so like they said in the last sentence there, you know, if the ideal thickness of the tortilla is 0.04 inches, what thickness would be guaranteed by this new equipment, right? Again, anything within 0.0, just add and subtract 0.005, which is all that was done here. Subtract 0.005, you get 0.035 for the low end. Add 0.005 to that ideal thickness, you get 0.045 inches for the high end. All right, so again, you could have done this without setting up an inequality, but you know the key behind the idea behind these exercises is to get you to practice setting up an absolute value inequality of this nature. All right, and then one last problem, one last example, example 4, which is exercise 493. This is basically the same, right? All 4 of these have pretty much the same setup. All right, so this one I'll write out. I'll do a little less writing, but it says, you know, at Lily's Bakery, the ideal weight of a loaf of bread is 24 ounces. By law, the actual weight can vary from the ideal by 1.5 ounces. What range of weight will be acceptable to the inspector without causing the bakery to be fined? Again, you can do this very easily. Take the ideal weight, 24 ounces, and then add and subtract 1.5 ounces, right? You can vary 1.5 ounces from the ideal weight. So the low end would be, you know, 22.5 ounces, right? 24 minus 1.5. And the high end would be 25.5. But let's say that the weight, right, the weights of a loaf of bread, let's say the weight of a loaf is represented by W, and then as in the previous ones, the absolute value of W minus 24, right, this is how far off of the ideal weight a loaf of bread is, right? Take the weight of the loaf of bread, subtract 24, and then take the absolute value, and that's how many ounces off our loaf of bread is from the ideal weight. And this can be no more than 1.5, right? This has to be less than or equal to 1.5 ounces. So again, without writing out all the words this time, I've set up my absolute value inequality. You know, the distance of the weight of a loaf of bread from the ideal weight can be no more than 1.5 ounces. And then I set up my, you know, the equivalent compound inequality, right? So this means that W minus 24 is between, inclusive, positive 1.5 and negative 1.5. Then I'm adding 24 to everything. So yeah, 22.5 over here. W in the middle is less than or equal to 25.5 over here. And you know, the range of acceptable weights for a loaf of bread, right, writing my complete sentence over here, the range of acceptable weights is 22.5 ounces to 25.5 ounces. Right, this is what the inspector would be looking for. And you know, anything less than 22.5, they'd get fined. Anything greater than 25.5, they'd get fined, because you know, it said by law, right, the actual weight can only vary from the ideal by 1.5 ounces. All right. So again, all 4 questions here, very, very similar setup. I'm hoping watching me go over these 4 here help you out when you're seeing similar problems related to, you know, setting up tolerances, setting up a range of acceptable values for something. And thank you very much for watching.